Selecting the proper AWS instance type matters. It can make or break your cloud apps and infrastructure. The decision isn't simply a matter of hardware. It's vital to scalability, performance, and cost-effectiveness in your AWS deployment. Why choosing the right AWS instance type is important. Picking the proper AWS instance type makes a difference. It determines how fast your app loads and how responsive it is. This also has an influence on how quickly you can meet business objectives. How it affects performance. The performance of your apps is largely based on which instance you use. Various instances offer different levels of power, memory, and storage. Scalability. Scalability is one of the largest benefits of cloud computing. Using the correct instance type allows you to rapidly scale resources depending on demand. Select the appropriate instance to ensure your app remains smooth. Cost efficiency. AWS has numerous instance types with different prices. It's important to choose one that fits your budget. Pick the proper instance for your app to balance performance and cost. When selecting an AWS instance, you must consider the needs of your app. This includes the amount of CPU power, memory, storage, and network bandwidth required. Section 1. Getting familiar with AWS instance types. What are AWS instance types? AWS supports many types of instances that are made to do various kinds of work. They are more like cloud computers, with their power, memory, storage space, and networking capacity. Various workload requirements. AWS instances are designed to address various kinds of needs. If your application requires a lot of computation, memory, or storage, there is an instance type that is just right for it. T-Series instances. T-Series instances for burstable workloads. T-Series instances are designed for workloads that sometimes need additional power. These models, like T2, T3, and T4G, offer a core level of CPU power but are able to burst or access additional power when necessary. This is fantastic for applications that don't consistently require a large amount of processing power but need a little increase at times. M-Series instances. M-Series instances for well-balanced resources. M-Series instances like M5 and M6G balance CPU, memory, and network power. Some of the uses of these memory-intensive instances are database servers. Applications such as databases require additional memory to cache and access data at high speeds. In memory caching, these instances are used to accelerate data access by caching data that is accessed most frequently in memory. Compute-optimized instances. C-Series instance. C-Series instances for compute-intensive workloads. C-Series instances are designed to support heavy computing workloads, including C5 and C6G. These instances are ideal for tasks that require a lot of processing, such as scientific simulations, video rendering, and batch processing. Where high-performance computing is required. Here are some examples of when to utilize C-Series instances. Scientific research, utilized for simulations and intricate calculations in science. 3D rendering and media processing, useful for 3D graphics generation and video processing. Financial modeling, used for calculating financial risks or simulations to be used for trading. R-Series instances. R-Series instances for memory-heavy apps. R-Series instances are designed for apps that need a lot of memory. R6G and R7 offer lots of RAM. This makes them great for tasks that need fast data processing in memory. Use cases such as in-memory databases and analytics. Here are a few uses of R-Series instances, optimized for memory, in-memory databases, ideal for rapid access usage, such as Redis. Stores and retrieves the data quickly. Big data analytics, it optimizes large data sets for quicker processing. Apps for real-time analysis or business intelligence become quicker. X-Series instances. X-Series instances with extreme memory. X-Series instances, such as X1E and X2GD, are designed for apps that require an enormous volume of memory. Scenarios that require a lot of memory, such as SAP HANA deployments. X-Series instances are commonly used by SAP HANA deployments. X series instances host SAP HANA, a special database that loads large data sets into memory to process them. Series instances. iSeries instances for high-performance storage. iSeries instances are meant to offer quick storage. Instances such as i3 and i4 offer a balance of computing power and storage speed, which makes them suitable for applications that require fast access to large data sets. Use cases such as NoSQL databases and data warehousing. iSeries instances are well suited for NoSQL databases. Such databases, such as MongoDB and Cassandra, require quick storage in order to function optimally. Data warehousing. iSeries instances efficiently store and process huge data. They reduce retrieval times and accelerate the overall process. D-series instances. D-series instances with local SSD storage. Local SSD storage is available on D-series instances, and that is extremely fast for temporary data. Instances such as D3 and D4 are made to be well suited at balancing computing power and storage speed. Scenarios where there is a need for fast access to temporary data. D-series instances are ideal for temporary file storage. These instances are suitable for applications that generate or require access to temporary files quickly. App caching. Caching supports apps to work more quickly through storing frequently utilized data. D-series is suitable for this due to its swift storage. P-series instances. P-series instances with GPU acceleration. P-series instances utilize graphics processing units, GPUs, to accelerate work. Instances such as P4 and P3 are suitable for tasks that require a lot of parallel processing, such as machine learning, 3D graphics, and simulations. Applications such as machine learning, deep learning, and graphics rendering. P-series instances are ideal for deep learning and machine learning. They require a high amount of processing. P-series instances utilize GPUs to accelerate training and testing models. F-series instances. F-series examples with FPGA acceleration. F-series instances utilize field programmable gate arrays, FPGAs, to accelerate workloads. These instances, such as F1, enable organizations to tailor the hardware to suit their particular requirements. Situations where customizable hardware acceleration is beneficial. F-series instances are beneficial in genomic research. FPGAs accelerate genomics research by rapidly processing large data sets. Selecting the right AWS instance types. Things to consider when selecting an AWS instance type. Keep a few things in mind. This makes your apps run efficiently, grow appropriately, and remain cost-effective. Here are a few important things to consider. 1. Compute needs. Determine the amount of compute required by your apps. If your app requires significant computing power, use a compute-optimized instance, such as C-series. If your app requires additional power at times, use T-series burstable instances. 2. Memory requirements. Consider how much memory your application requires. If your application requires a lot of memory, select memory-optimized instances, such as R-series or X-series. If your application requires a balance of memory and compute resources, select general-purpose instances, such as M-series. 3. Storage requirements. Determine how much storage and performance you require for your application. If your application requires high-performance storage, select storage-optimized instances, such as iSeries. If you require rapid access to temporary data, look for instances with local SSD storage, such as D-series. 4. Accelerated computing. Check whether you require more power. You may require GPU acceleration, P-series, or FPGA acceleration, F-series, for applications such as machine learning or graphics rendering. 5. Network performance. Consider how much network bandwidth and speed your application requires. Select instances with improved networking if you require high throughput. 6. Scalability. Think about how much your app may need to scale. Choose instances that can scale up, increasing power to an existing instance, or scale out, adding instances as needed. 7. Cost factors. Consider pricing models such as on-demand, reserved, or spot instances to reduce costs. Weigh your performance requirements against cost-effectiveness. Keep an eye on CPU credits for burstable instances to manage costs. 8. Instance families and generations. Know which instance families, C, M, R, and generations, T2, M5, R6G, will suit your app's requirements. Newer generations tend to have superior technology and performance. 9. Security and compliance. Ensure the instance type is compliant with security requirements in your industry. 10. Geographic location. Verify whether the instance type you require is supported in the AWS regions where your app will be deployed. Real-world examples. Following are some examples of how companies select the appropriate AWS instance type for their requirements. Example 1. E-commerce website. Compute needs. Choose M series for a good balance of memory and power to host the website and database. Storage requirements. Utilize iSeries for high-speed storage to host the database. Scalability. Choose instances that are horizontally scalable to manage increased traffic during sales or promotions. Example 2. Data analytics platform. Memory requirements. Utilize iSeries to analyze large datasets with speed for enhanced analytics performance. Accelerated compute. If machine learning is employed on the platform, utilize P-Series for GPU capability to accelerate training. Cost factors. Leverage a combination of reserved and on-demand instances to reduce expenses based on predictability of the workload. Conclusion. Picking the right AWS instance is important for making your apps run fast, scale easily, and stay affordable. Each instance type is designed for different tasks, like handling lots of data, running powerful programs, or storing information quickly. By understanding what your app needs, you can choose the best option. This helps your apps work smoothly, grow when